Hello everyone and welcome to SQL Friday. This is SQL Friday number 41 and our star today is Dennis Torres. I first saw Dennis when he was a speaker at Speaker Idol on PASS Summit 2018. I don't think you won, but I think you were one of the finalists. Not sure because I saw all the sessions, so I saw you at least twice. Welcome to SQL Friday, Dennis. The stage is all yours.
Thank you very much. Thank you very much, Magnus. So, uh, let me share my slides here. So, welcome everyone. Uh, Today I'll be talking about data visualization and data lake using SQL Big Data Cluster. My name is Dennis Torres. I'm a data platform MVP and I live in Malta. I'm a trainer with some certifications, and you can see all my contacts. It will be a pleasure to get in touch and connect. Please ask me any questions on my contacts. I will also leave with you another link because I'm preparing a big conference. It would be a SQL Saturday, but we don't have SQL Saturdays anymore. So it's the Malta Data Saturday. You can see on this link the information about the Malta Data Saturday, and you can hashtag it to be in April, and it will have many very good speakers on the Data Saturday. It will be very nice. So, our agenda today. First, some disclaimers. Big data cluster is a very broad subject, a very broad subject. For you to have an idea, on the last PES Summit, on the virtual PES Summit that we had, there was an entire learning path for the big data cluster, and I delivered one of the sessions. This was one of the sessions in the middle of a learning path. And in the SQL the last SQL this session was transformed in two because it became too long. So they gave me the space to deliver two sessions, part one and part two of a big session. And thank you then for that. So this is a very broad subject. So we'll see what it is, why is this important. I'll show some demonstrations, but it's important to get more information about these. The videos for PES Summit are available on YouTube. SQL is preparing something very interesting to release the videos from SQL and so on. So let's start. Let's talking about what it is and why is this important. First, we'll talk a bit about theory. What a data lake is. Let's talk about past and future about this uh, theories. What's data virtualization and why is this important? Then what's big data cluster? And let's talk about data virtualization in SQL Big Data Cluster. Uh, Mind that this session was prepared uh, to focus on a specific subject, data virtualization in SQL Big Data Cluster, because SQL Big Data Cluster by itself is a huge subject. So what's a data lake? So first we got big data. When internet came, we got big data because the amount of information we got from our the sources from our application was too huge. Imagine a web application, for example, trying to log which pages the user is accessing. It's too much information. The same happens with mobile apps, for example. A mobile app distributed all around the world. Uh, it's too many information to collect. So we got big data, a huge amount of data that we need to organize correctly. Otherwise, we will end up as this small cartoon here. We need to make a code organization with big data. By the way, a side note, I took a Microsoft exam a few days ago, a bit exam. Every time Microsoft create new exams and new certifications, I try them out. And the exam was for Azure Data Engineer. And it's interesting how it's demanding knowledge about organization of big data, how big data is organized in theory, not only in relation to the technology. Then we got big data, and what happens? Uh, we talk about big data, big data, big data, but what is big data? It's a SQL database to be? No. Big data is a so huge amount of data that we can't leave it in a relational database. First, first thing that we can note is the incoming data. The incoming data is so much and so fast that SQL Server may not handle the amount of data incoming. So we create uh, streams of data like event and use technologies like Event Hub, Kafka, and so on to get these streams of data and make some work with these streams of data because it's too much for SQL Server. SQL Server made a very good attempt to keep up with this. Uh, when including in-memory tables. But even so, it's too huge. And now we have Azure History Analytics. And for the ones that are older, if you may remember, remind this, History Analytics was born together SQL Server. It was a new tool with SQL Server, and now we have in Azure has a isolated tool. And big data brought to us the concept of data lake. Uh, what's a data lake? Why big data brought data lake? Because the amount of data that big data involves is so huge that we can't keep moving data around. Before big data, before this time, sorry, the bell here is ringing. My wife will take care of this. Not sure if it was in the sound, but let's go. So,
We just barely heard it. No problem.
okay. So, the amount of data that big data involves is so huge that we can't keep moving it around. Uh, Before big data, we were used to send data to the application that we needed to. If we need to the application A to process the data, we use it to import the data in application A. If the application B needs to process the data, we import the data in application B. These were very old times because now the amount of data is so huge that we can't stay moving the data like this. So the data needs to be in one place, need to be stored in one place, and it will be there. And it's the task of the applications to go to this place and get the data that they need and process the data they need in this place. And this place is the data lake. So the idea of the data lake is that the data lake is the storage for big data. And we call data lake because the data is there, is static. It doesn't move. We don't keep moving the data. And Exactly as big data, we need to have a good organization, otherwise the data lake becomes a data swamp. And this word is already being used around to talk about bad data lakes that are bad organized. And that's what I was talking about. The data is stored in the data lake, and many applications will go to the data lake to process the data. So we don't keep moving the data around because it's too much. So many applications go to the data lake to process that data. But to better understand all this, let's make a tour to the not so past. It's not really past, but many people may think this is old past. What I'm talking about? I'm talking the data warehouse, the concept of data warehouse. We're used to it, and nowadays, if I talk about a data warehouse, many people think, "Oh, this is too old. We use new concepts now." Not exactly. The data warehouse is very needed in our applications, in our scenarios. The data warehouse is the central storage of historical data for the companies, is where we store relational historical data, but not in a normalized way. We have different modeling methods for the data warehouse. Like here, you are seeing a star model for the data warehouse. So on the data warehouse, we use different modeling methods. So getting back to the future, what happens? Many people consider the data warehouse the storage for structured data, relational data, and structured data. That's partially true. Yes, the data warehouse is where we store structured data. Although the original theory about the data warehouse has more than that. And some of these concepts have been missed by many, but I will not go so deep on this. But we can consider the data house as the storage for structured data, and the data lake is the storage for unstructured data in an amount so big that we consider it big data. So we have two kinds of storage and data centralization in the company. So we have a data warehouse and a data lake. And sometimes the same application can generate information that goes partially to a data warehouse and partially to a data lake. It happens according to the amount of information generated. Then both of them decided to marry, go to a honeymoon, and what we got from there? We got the idea of a data lake house. So the data lake house is the idea of having a data lake and a data warehouse working together to make both work together to control our data. Uh, let's imagine a request made by a manager. So the manager requests, "Oh, I would like you to analyze the data that we have from Twitter that we imported in a storage environment that we have. It's stored in ADFS. So I would like you to analyze this data, but I would like you to merge this data with the customer information that we have on SQL Server, so we can understand the feedback our customers are giving to us on Twitter and how our customers are getting involved with us on Twitter. However, a few weeks ago, we bought a new company, another company, and their data is stored in Oracle, and they have customer data as well, is stored in Oracle, and they would like you to merge this information with the customer data in Oracle as well. And according the manager is explaining this request, you are already thinking, so we'll need to make a huge ETL package get data from the DFS, get data from SQL Server, get data from Oracle. So this may take 1 week, 2 weeks to do, and then the manager makes his final request. How would you solve this? And his final request is he needs this for the meeting in 1 hour. He needs this query done in 1 hour for the meeting. So what you do? You lose your mind. How will you solve this problem in 1 hour? That's the idea of the data lake house. All my explanation about the data lake house involves the storage, the idea that we have a data lake and we have a data warehouse working together. But what is working together of a data lake and data warehouse? Is to have a tool capable to solve this kind of request. Have a single tool capable to get data from the data lake and from data warehouse and even multiple data warehouse and handle this request in a single query. That's the idea of a data lake house. And there are very few tools in the market capable to do that, to handle this request in a single query. One of the tools capable to do that is SQL Server Big Data Cluster. Big Data Cluster arrived with SQL Server 2019. Is an installation of SQL Server made in a SQL Server environment made inside Kubernetes, but it's a bit more complex than that. Let's talk about this. But before, what's data virtualization? Because the subject of this essay is data virtualization, so it's even beyond that request. So what's data virtualization? To understand what's data virtualization and why it's needed, let's imagine how the data is built inside an enterprise environment, but then we are talking about a very big enterprise environment. A big enterprise environment that has a main office, has many branches around Europe, North America, Asia, and branches on each country. Many different countries. And what happens? How the data will evolve? Usually what happens is that each branch has their own needs, and their needs are so immediate. They need a result at the moment, so each branch build their own data solution, use a departmental IT. And this doesn't mean to be only a production solution. If it were only a production solution, we could think about, oh, let's make an ETL from production and build a warehouse or data lake. But not only a production solution, each branch will need an analytics solution as well, and they will build it. So when the enterprise IT thinks, oh, now we are good, well organized, we are a worldwide company, we need good analytics to get information from our branches. So when your enterprise IT gets this into mind, all the branches already have an analytics solution in different products, in different formats, in different methods, and nothing meshed together. So what the enterprise IT needs to do, how the enterprise environment will build a centralized analysis solution without these different environments. That's the point. And this point is related as well with the concept of the data lake. And the concept of the data lake is that we will not move the data. There is no meaning of moving the data. Leave the data there, and the applications that need that data will come and make analysis over that data. So if these branches already built their own data lake, What should you do? Move your data lake? No, too much. So that's where we got the concept of data virtualization, a data virtualization platform. This means that we can create a logical data lake, a virtual data lake, and connect many different systems on this virtual data lake. So we build the virtual data lake and connect different systems on this virtual data lake. And what will happen? Applications will be able to make a connection to this virtual data lake as if it is a database connection, for example, and execute queries on this virtual data lake, execute a single SQL query on this virtual data lake, getting data that may be coming from many different branches of the company, for example. The data may be coming from many different branches, and a single query can get this data. Exactly like the problem that I showed before. A single query can join different types of data in different ways. And for the application, this is still a single SQL query. That's the idea. And how data virtualization works in SQL Big Data Cluster. Data virtualization tools that we have inside a SQL Big Data Cluster. We use the concept of external tables. So we can create an external table, a table that is located in an external location. So we can define a table from an external location and our queries will be executed over that table. And the user that will execute the query will not mind if the table is there or not. If the date of the table is stored in the same physical place or not. Another tool that we have is ADFS, tiling amount of ADFS or amount of ADFS. What is this? The environment of SQL Big Data Cluster, the idea is to be a data lake house. So the SQL Big Data Cluster has a data warehouse where we can use external tables to connect, to virtualize other environments. And we have a data lake that use ADFS. We can have local data on our ADFS, but we can virtualize external ADFS environment use ADFS tiling. We mount remote environments as if they were local folders. So when processing ADFS, everything that we make to process the ADFS will see the environments as if they were local folders when in fact they are a remote environment, as those branches, for example. And we have the concept of pushdown. The concept of pushdown is very important in the data virtualization. What's the concept of pushdown? We are talking about making queries over this virtualization. Imagine a SQL query. A SQL query has group by, has where clause, and so on. How this would be made over a virtual environment, a set of data that is in another place. How this would happen? That's the point. That's where the pushdown comes into place. The idea is that according the capabilities of each remote system, the SQL Big Data Cluster can decide what will be pushed down or not. For example, the where clause can be completely pushed down to remote environments. So the BDC will not retrieve all the data and make the filter locally. Will push down the where clause and the remote system will make the where clause and make the filters. Group bys can be pushed down and so on. So pieces of our SQL query can be pushed down to remote environments to be processed in remote environments, and then we get back the result of those pieces, and the BDC merge the results and provide to us the result. So these are the tools that we have for virtualization in BDC, in SQL Big Data Cluster. We have external tables, a DFS tagging, and push down. So we can fulfill this request, the request from the manager. We can make this in a single query, and we can make this in way less than 1 hour to solve the manager problem and deliver the data for the manager. What we need to solve this problem is a virtual data lakehouse solution in order to get the information from all the remote environments. So, now that we understand better the concept, let's talk a bit about what's Big Data Cluster, because I'm talking too much about Big Data Cluster, BDC, SQL BDC, but what's SQL BDC? Is this a new feature inside SQL Server? We can think it is about a new feature inside SQL Server, but you notice this is a completely new installation of SQL Server. You may better think about this as a new edition of SQL Server in the same way that you install a SQL Server Standard, a SQL Server Developer, a SQL Server Enterprise. You install a SQL Server BDC, but the installation is not that easy. Big Data Cluster is a set of capabilities introduced with the SQL Server 2019 release. So it allows to deploy scalable clusters of containerized instance of SQL Server. So we'll have SQL Server clusters inside Kubernetes. And we'll have Spark and Hadoop data file system, ATFS, inside the same environment, using Kubernetes as the orchestration engine and SQL Server orchestrating the work between a SQL Server data cluster, a data warehouse, and a Hadoop cluster, a Spark cluster to say better. And all that we are talking about involves what is called an MPP architecture, massive parallel processing architecture. The idea of the massive parallel processing architecture is that we have a control node, and the control node is ready to receive queries from applications. Then, to execute these queries, the control node will break down these queries in compute nodes. Each compute node will execute a piece of these queries, and then the control node will retrieve the result of the execution, merge the result of the execution, and give it back to us. How this works with BDC? The point of BDC is that considering this MPP architecture, we have one MPP architecture for the data warehouse inside BDC for a SQL Server clusters. One MPP architecture for the Spark environment, for the data lake environment inside the BDC. So we have two clusters, one SQL Server cluster and one Spark cluster working together. And in the middle of this, we have the virtualization capabilities. This cluster can virtualize data that is located remotely and get the data using the features I talked about. That's the idea. So let's start talking about the cluster architecture, the BDC architecture. We have a master instance, SQL Server master instance. Then custom apps, BI analytics will make queries to this master instance. This master instance controls the BDC environment. And what else we have on the BDC environment besides the master instance where the request goes? First, to control the entire cluster, we're talking about a huge cluster inside Kubernetes. Kubernetes uh, uh, also have a control plane, not Kubernetes, but the big data cluster installed inside Kubernetes build a control plane for the environment. So we have an environment where we can know what's happening inside the clusters. So we have these tools, Kibana, Grafana, Elasticsearch, all these tools that will control the BDC environment. Then we have the compute pool, and the compute pool is the data warehouse part. We have the SQL compute nodes on the compute pool. And we can have pools with different, not one single pool. We can have multiple compute pools and with different number of nodes inside each compute pool. This is allowed by the BDC environment, so we have an scalable environment. And we can have the external tables using external data sources and go get data from external SQL servers, Mongo, Teradata, Oracle, many other external data sources, creating the virtualization result. And besides that, we also have a storage pool. And inside the storage pool, we have a Spark cluster pool that controls the data lake feature with ADFS data nodes. And these each of these nodes with a Spark, a SQL Server, and ADFS node, data node is inside a Kubernetes pod. And on the ADFS data node, we can make the ADFS tagging that we will mount remote ADFS environments, remote data lakes. And the master instance can read directly from ADFS, can connect directly with the Spark pool, or can use the compute pool to connect to the Spark pool. There are many different solutions to process some queries. So these may need to be well planned. And all this is stored in Kubernetes nodes. Kubernetes nodes with many Kubernetes pods deployed. So at this point we have a demonstration. Now I need to say sorry for one small problem, is that as you are seeing, the big data cluster environment is huge. I started deploying one this morning for this session, but it was not deployed in time, and I had some unforeseen problems that I was not able to deploy the environment. So for the demo, instead of making a live demo, I will not be able to make a live demo because I don't have the environment deployed. I will show you a recorded demo from a previous session. I think you can see my screen. I'm already maximizing a recorded demo, and SQL Big Data Cluster, and this works. Confirm to me that you can hear the sound of this demo.
I can hear the sound, yeah.
Yeah. So sorry for to be showing a recorded demo.
Explain
And I will take
step
on the
by
chat, and we
step
will be available to
how to deploy
answer
the
any
SQL
questions.
Big Data Cluster. Your first deployment will follow these steps. Your first deployment will be a guided deployment following these steps. After that, after you get some understanding of the environment, then you'll be able to customize the deploy according to your needs. But your first deployment for sure will be a basic deploy following the workshop. You ask, where is the link of the workshop? I will show in the end. I will show the link for the workshop in the end. So let's start the demonstration. Here, I'm using Azure Data Studio. As you may notice, Azure Data Studio. To deal with big data cluster, Azure Data Studio is the best tool. The best. And here I can see the master node. I'm connected to the master node of the big data cluster. And what's different here? What's different here is the DFS folder. A DFS folder is completely different. Yes, we have an ADFS storage inside SQL Server. That's what we are seeing here, an ADFS storage inside SQL Server. The unmount is done, the delete of the mount is done. So now I'll make a refresh, and that's it. The mounts are not there anymore. No mount there anymore. So let's start from the very beginning. It's interesting to notice the architecture that we have. First, we can go to the Azure portal. Here in the Azure portal, I can check the pods that we have inside the SQL Big Data Kubernetes service. SQL Big Data is the name of the Kubernetes service. And we have all these pods created inside this Kubernetes service. No, I haven't created one by one. I followed a process to deploy SQL Server Big Data Cluster, and these pods were created. Let's highlight some details here. Note that we have two pods of data, 00 and 01. This means that we have two nodes for data. The data pool that was talking about. We have two pods for storage, 00 and 01. So we have two nodes for storage, the storage pool I talked about before. But we have only a single pod for compute. Because when I built the big data cluster, I asked for a single pod of compute. It's only for demonstration. Of course, it doesn't make much sense to have a single compute pod. It just doesn't make much sense. It's just for a demonstration. The other pods are control pods, pods for the master, and for the additional monitoring services, such as a problem about the certificate of an environment, and it's not important on a sample. So here I have the Grafana environment, and I can manage the environment, get pods and containers metrics. And here I can see the pods that we have, and I confirm again that we have one compute node, one compute pod, two data pods, and the storage pods are a bit below. I can get one data pod, for example. No, let's get the compute pod. And I can check the activity in the compute pod using Grafana. Okay, all this that I did until now is only to show to you a vision of the environment, give you a small vision of the environment. Let's start some more active demonstrations. Let me open one file, open file. I have here a quiz demonstration. I will use the sales database. First, when I'm accessing information in ADFS, unstructured information, I need to define carefully what's the format of this information. So we have a concept of an external file format. It's an object that we use to specify the format of the information. So I will create this object. Let me open sales here. Highlight that we have external resources inside the database sales, external data sources, and external file formats. And we have some external file formats already created here, because of course I forgot to delete them before, but since they are created, let's leave like that. And this is the statement to create the external file format. Next step, after creating the external file format, I can, inside the SQL database, create an external data source. An external data source in the SQL database will be pointing to an external place. So I can retrieve information from the external place. That's the idea of the data virtualization. Many applications will be able to query this SQL database, making queries over the table without knowing the information is in a completely different place. So, I can execute this, will not make any problem, but the fact is that this sales database already has this external data source and many others. SQL storage pool is already here. This is not a default. This was created by the step-by-step of the workshop that I talked about. I said about. The workshop provided by Microsoft create this environment with the sales database with these data sources. But what I need to highlight is that these data sources created here are very, let's say, very basic data sources, extremely basic data sources. And we need to have them probably in every database that we will create inside our environment. Every database will need these data sources. Take a look here. The location of the data source. Controller SVC, the controller service of our cluster, and the full, and the protocol SQL ADFS. So we are accessing the storage pool. Creating a data source on this, with this format are giving access to us to our storage pool. So from SQL, using SQL queries, I'll be able to query the information which is in the ADFS storage pool. That's it. Since there is an if here to check if it exists, I can execute this with no problem. Nothing will really happen. Now, let's create an external table. Create external table, web click string ADFS. The table has this end in the name ADFS to identify the table is inside the storage pool, inside the ADFS environment. We have the structure of the table, the fields as begin, but note the last part. We have the data source, SQL storage pool. The data source says that the table is inside the storage pool. That's it, nothing more. But we have here the path where the table is. The table is inside the folder click string data. So inside the storage pool, the folder click string data will be mapped to this table. But a folder can contain many files. Yes, it's how ADFS works. You can map a folder to a table, and all the files will be read and loaded as part of the table. And the file format. Which format of the file are we dealing with? We are dealing with a CSV file. This is the name of the file format created before. The object file format sets the format of the file. So let's create this table where we click string ADFS. That's it. Let's make a simple select over this table. Select top 100 from web click string strings ADFS. That's it. We are reading in SQL information that is contained in a CSV file inside my ADFS environment. That's it. Just that. Now, let's make something more interesting. I don't need only to read the information. I can process the information, make calculations with this information. I have here this query. With this query, I'm getting my external table, which is inside ADFS. My external table is inside ADFS. Here. And I'm joining this table with a table item and making a grouping by. So I'm joining a table which is in the ADFS, is in a CSV, with a table which is inside my database. I'm making a join of them. So let's make a join of them. That's it. So it's processing. And in some more seconds, I'm joining a CSV to a SQL table. There it is, 88,000 rows as a result, 88,000 rows, resulting on the join of the CSV table in the ADFS environment and the SQL table. That's it. So in one query, I join it both together. And the applications don't need to know where these tables are. The applications don't need to know. They will only make SQL queries. Just that. Our environment will be a virtual data lake, a data virtualization platform. The information is here, the application thinks the information is here, but our external tables are able to get information from external environments. On this example, I use this external data source, which is called SQL storage pool. This means that I made my master, I'm connected to the master, read information directly from the DFS. The master went directly to the DFS. But I have other data sources here. I have a data source called Hadoop data. In this case, instead of going directly to a DFS, my SQL master will request the information to the Spark endpoint. And the Spark will make a job to retrieve the data from the DFS. So I will create another table is absolutely equal the previous table, but this time I changed the name. Of course, I can't create with the same name. I changed the name to the end of Spark, and I changed the data source, Hadoop data. So this time I'm reading information from a different data source. That's it. So let's make this select top 100 from web, click strings, Spark. Let's execute. That's it. So we have the result. Now it was read through Spark and not through directly from ATFS. How can I understand this? How can I discover this, that this was read through Spark? Well, to identify this kind of thing, we need to monitor system tables. Like, for example, we have here the sysdm exec distributed requests. So I can execute this query and it will list for me the last distributed request which happened. The last distributed request executed. Probably according to the total elapsed time. I think this one is the QID 239. Let's check. Then I use the system view system exec DMS workers. What's DMS? DMS is a set that follows Polybase, was created since SQL 2016. It's called data movement sets. It's a set responsible to move data among the nodes, the data nodes. So the DMS will show to us the steps executed. I'm filtering these steps because I know what I'm looking for to identify what happened. So I have here external reader going to the ADFS. And parallel copy reader. Why do we have this parallel copy reader? The point is the environment identifier that the information was read just a few seconds before and used cache. But the important part is that we have two external readers going to the endpoint ADFS. The ADFS endpoint means that they are going to Spark. And here we see our queries distributed, easily distributed. Okay, to make it better, we need to repeat the other query and identify the difference. Let's repeat this other query, which is reading the data now from ADFS, directly from ADFS. Run. Then the data is there. Then let's check the distributed requests. So the elapsed time was very low, probably this 149. Let's confirm that is 149. I will query the sysdm exec DMS workers. And now I have many external readers. Many external readers. I don't have only two external readers. I have many external readers. Why I have many external readers? Because each one is completing part of the task to read the SQL ADFS. Mind the protocol SQL ADFS. So it is going directly to the external reader to complete this task. When we were using Spark, we had only two external readers, and the problem was a Spark problem. The problem was sent to Spark. But now, reading directly from ADFS, we need to have many external readers to read the ADFS. So we can identify using these system tables if the query was using the data source, was using Spark or reading directly from the ADFS. And there is a difference on this. The difference is the ability to push down. If we are using Spark, we have the ability to push down to a Spark job. If we are not using Spark, we don't have the ability to make the push down. We can't make the push down. And that's a problem. That's a problem. These other samples are exactly the same. I just changed the order of the demonstration bit. Let's go ahead and create a new file format. This file format is a compressed file format, and that's very interesting. When we talk about file format, we are not only talking about CSV or Parquet. I can have a compressed file format using gzip compression, gzip codec. So let's create this compressed file format we will use in a while. Already exists. I forgot to delete them from my previous test. It's there already. Let's create a schema called est. Already exists. I forgot to delete it. And now I'll create the table trip. Create external table trip. This external table is going to a folder called New York Taxi Trip 2013 and using the compressed CSV it will read data compressed. But what is this New York Taxi folder? I don't think we have a New York Taxi folder. If you check, we check our ADFS environment. In fact, we don't have a New York Taxi folder because this New York Taxi is a public blob storage maintained by Microsoft, providing a lot of information that we can use for samples and tests and so on. But it's not here, it's not local, it's a remote blob storage provided by Microsoft, but it's public. There isn't any kind of authentication for this blob storage. So what I need to do, I need to mount this blob storage. So I get the instruction to mount this blob storage, which is AZ data, BDC ADFS mount. Create remote URI, WASPS, and the address of the blob storage and container. Mount path, New York Taxi. So I'm mounting an external blob storage as a path of my local ATFS storage. This time, I remember to not close this window. Okay. I'll paste this instruction here. And that's it. The mount request was submitted to mount the external blob storage in our local ATFS. Let's make a refresh. Mine the folder NI taxi. At this moment that I immediately made the mount, is not showing the symbol that this is a mounted folder. But if I close and get back, the symbol will appear. It's a bug on the visual interface. And I'm seeing the content of this folder. There are a lot of data here. Each folder is a table, is intended to be a table. And the trip 2013, mine that is TXT, GZ, is a compressed CSV. So I already created the format, and I will use my local data source. I will use the Hadoop data and execute. So I just created this external table, and let's make a select. And I'll make a select of 100 records. That's it. I just read 100 records from a blob storage that is somewhere on Microsoft environment. I have no idea where it is. It's not on my environment. And I retrieve the data as it were local to my SQL server.
We are running out of time for this SQL Friday, I know, but I think I could deliver a good taste of what big data is big data cluster is, and what we can do with it, and it's very interesting. And the how to go further. The learning path of the last past summit was very good, and it's available on YouTube. And in a few days, weeks, Bits will also make a release of the videos, and I will be releasing the big data cluster that I made for Bits as well. So I hope you liked this demonstration. If you have any questions, please feel free to ask, or you can connect with my contacts. Let me share my contacts again. You can connect with my contacts and ask me anything, any question about the subject or the subject. And thank you very much for attending. I hope you liked the session, although I hadn't time to prepare a real live demonstration, but I hope the recording gave you a good idea of what BDC is capable of.
Yeah, I mean, you had a recording. I'm impressed by that. So you had like a a backup plan in case the deployment
Yeah.
didn't go in time. So that's good.
Yeah.
I need to run to another meeting, but thank you so much, Dennis, for coming to SQL Friday, and I hope we will be able to travel again, and then I will come to Malta and have a beer with you.
Thank you very much for the invitation. It was a pleasure. Hope anytime we can schedule any other one at any time. Thank you very much.
Thank you. Bye.
See you.